Today we will discuss about the introduction of trigonometry. And now in this chapter let us understand the introduction. We have already studied about triangles and its particular right triangles in your earlier classes. Let us take some examples from our surrounding where right triangles can be imagined to be focused. For instance, point number one, suppose the student of the school are visiting Qutub Minar. Now, if a student looking the top of the Minar at a right triangle can be imagined to be given as shown in the figure 8.1. Can the student find out the height of the Minar without actual measuring it? So basically this is the boy and this is a Qutub Minar which is a perpendicular. As a right angle triangle, this is a perpendicular and this is a hypotenuse and this is a adjacent side or base. And point number two, suppose a girl is sitting in the balcony of her house located on the bank of the river. She is looking down at the flower pot placed on the stairs of the temple situated near on the other bank of the river. A right triangle is imagined to be made in this situation according to the given diagram. If you know the height of at which the person is sitting, can you find the width of the river? This is a basically girl on the balcony and this is a flower pot. Flower pot. So she is seeing this flower pot and find this length. So basically here this will be the perpendicular. This is a perpendicular and this is the adjacent side or base and this is a hypotenuse. So this is also this phenomena also make a right angle triangle. And now situation number third, suppose a hot air balloon is flying in the air. A girl happened to spot the balloon on the sky and run to her mother to tell her about it. Her mother rushes out of the house and look at the balloon. Now when the girl has spotted the balloon, initially it was at a point A. And when the both mother and the daughter come out to see, it has already traveled and to another point B. Can you find the altitude of B from the ground? So actually when girls come here first in this point, she saw the balloon at the point of A and she called the mother and both come together again at that point. Then this balloon position after some time will be at the point B. And now we can find the altitude. This is altitude. So basically from this point, this will be the distance from the ground and this will be hypotenuse. Altitude always will be the perpendicular. So this is a perpendicular side and this is the adjacent side. This is the adjacent side. So this will be the right angle triangle for this phenomena. So we can also use in this phenomena the right angle triangle. In all the studies given above, the distance or height, distance and the height can be found by using some mathematical techniques which come under the branch of the mathematics called trigonometry. All these phenomena comes under the branch of the mathematics, that mathematics called trigonometry. In this we can use height and hypotenuse and adjacent side of a triangle. That triangle is called a right angle triangle. Now let us understand something about the word trigonometry. The word trigonometry is derived from the Greek words tri mean three and gon means sides, and the metron meaning measurement. So trigonometry basically divided into three parts. Tri mean three, gon mean sides, and metron mean measurement. So the meaning of the word is the measurement of the side of a right angle triangle. In fact, the triangle is the study of relationship between the sides angles of a triangle. Trigonometry is the study of relationship between the sides and angles of a triangle, and the earliest known work on the trigonometry was recovered by Egypt and Babylon. Early astronomers used it to find the distance of the stars and planets. Find the distance of stars and planets from the Earth. Even today, most of the technological advanced methods use in engineering and physical sciences and based on the trigonometrical concept. In this chapter, we will study the same ratios of the sides of a right angle triangle and respect of this acute angle. All triangle called trigonometric ratio of the triangle. We will restrict our discussion for the acute angle only. However, these ratios can be extended to the other angle also. We will also define the trigonometric ratio for the angle of the measure 0 degree and the 90 degree. We will calculate the trigonometric ratio for some specific angles and establish some identities involve these ratios called trigonometric identities. So second topic from this chapter is a trigonometric ratio. Let us understand about the trigonometric ratio. This is a right angle triangle. This figure is called a right angle triangle. Right angle triangle which include a hypotenuse and side opposite to the angle A, this side opposite to the angle A, and side adjacent to the angle A. So basically, this is the longest side of this triangle. Reason is that the greatest angle is B, so opposite side always will be the longest side of this triangle. So AC will be the longest side of this triangle. So that's why this is called the hypotenuse of this right angle triangle, and this side is a perpendicular to this side. So this is a perpendicular, this is the adjacent side of a triangle A. Now let us make a right angle triangle as shown in the figure. Here angle CAB, or in the brief angle A, is the acute angle. Note the position of the side of the BC with respect to angle A. In fact, angle A we call it the side opposite to the angle A. We call the side opposite to angle A, AC is the hypotenuse and of the right angle triangle, and the side AB is the part of the angle A. So we call it the side of the adjacent of the right angle triangle. Note that the position of the side changes when you consider angle C in place of A. Suppose if you want to take this angle, and now so this will be the hypotenuse will be the same, but this side will be perpendicular opposite to the vertex C. So this will be the perpendicular side, and this will be the adjacent or base of the side, base. But here this we have taken this angle, so this will be the perpendicular, and this is a base. This side will be the base. So basically this is a difference to taking the angle. Suppose we in this figure we can take this angle for the calculation. So this will be the base side, or this will be the base side, and this will be the perpendicular side of a triangle. After that, the trigonometric ratio of the angle A in the right angle triangle ABC are defined as follows. Sine of angle A, side opposite to angle A, BC, and hypotenuse AC. And basically this will be the ratio of the sine with angle A, and cosine with angle A will be side opposite to the angle A over hypotenuse, so AB over AC. So similarly the tangent, cotangent, secant, or cotangent, tangent, all these side we can explain like that. So basically this is the introduction of the trigonometry in this class, and the ratio is defined abbreviate as a sine, cos, tan, cosec, and sec, and tan respectively. These all the shortest form of this trigonometric ratio. Note that cosec A, sec A, and cot A are respectively the reciprocal of the sine A, cos A, and tan A. So, and tan A is equal to sine A upon cos A, and cot A is equal to cos A upon sine A. So basically this is a small discussion of the introduction of the trigonometry. Thank you so much.